In this session, we will be, in the previous session, we have discussed about the multiplication principle, addition principle, and the counter projective principle. Now, in this session, we will be discussing about few of the commonly used words which are used in counting. These words are used in a different way. So, we divide these two words as arrangement and subsets. And we will use these counting principles like addition principle and multiplication principle to see how these two things are related, right? So let's get started with the word called arrangement, right? So what is an arrangement? Arrangement. So it could be formatted into few ways. So for example, you can say how many 3-digit number can be formed from, let's say, set n4, which is the first four elements of first four natural numbers, right? Where repetition is not allowed. Repetition is not allowed. Or you can always say the same thing in a slightly different fashion, saying that arrange four different numbers. Let's say 1, 2, 3, 4 again, right? In a row, taken R at a time, 3 at a time, right? You can also say like this, that arrange, so let's say we have set n4 again, which is 1, 2, 3, 4, 3, 4, right? Now, how many ways you can put 3 numbers from this set, n4 and set n4, and put these 3 numbers in a row. So these are the various ways where the problem can be stated, but all these things means the same. So it basically means that you have a 3 different, you can say, spaces, and you want to arrange 4 different numbers or objects into these spaces, right? So let's see how we are going to approach these things. So let's take this part where we say arrange 4 different numbers, 1, 2, 3, 4, taken 3 at a time, or you can say how many 3-digit numbers can be formed from n4, which is 1, 2, 3, 4, where repetition is not allowed, right? So let's try to enumerate all this and see how we can do that, right? So we will try to form all the 3-digit numbers from 1, 2, 3, 4, such that repetition of numbers are not allowed. When I say repetition is not allowed, meaning we cannot put 1, 1, 2 or 1, 2, 3, 1, 1, 1, 2, 1, 1, 3 or something like that, where no numbers are repeated, right? So let's try to write all these numbers here. So the first number which we can write is 123, that is 1, 2, 3. Now, if you look at them, since it is a number, here ordering is important because 132 is different from 123. Similarly, you can write 124, and then again you can change the position of 4 and 2. Similarly, you can write, so we have to write with 132, right? So 1, 2, 3, right? So we can write 2, 1, 3, then we can write 2, 3, 1. So we can write 3, 1, 2 and 3, 2, 1. So this can be written into 6 ways. So you will see here that 1, 2, 3 can be rearranged among themselves via 6 ways. The second combination which we can try to use here is 1 to 4 because it doesn't use the same elements 1 to 3. So it is 1 to 4. It's a different combination. So you can always arrange them into 6 ways again. So we can try to do that. 41. Then you can use 4. Then we are left with 1, 2, and then you can always do 4 to 1. Again, that can be done in 6 ways. Right. Now the third combination which we can try of between 1, 2, 3, 4 is which does not contain 1, 2, 3 or 1, 2, 4 at all. So that could be 1, 3, 4. Now this can be again rearranged in such a way that there could be 6 numbers from it. So we will write down all these numbers starting with 1, then we move to 3. So we are left with 1, 4. Then we have 3, 4, 1. Then we move to 4. Then we are left with 1, 3 and 4, 3, 1. Right. The last combination which we can use is 2, 3, 4. Right. So we can again rearrange it into 6 ways. Now we go with a 3. So we are left with 2, 4. Right. You can see all these numbers can be formed. And now we go with the 4. So you are left with 2, 3. And we go with the 4 again. 4, 3. So again 6 ways. Now, what is the total number of ways of arranging 3-digit numbers among these 4 numbers 1, 2, 3, 4? So you can simply count it that it can be done via 24 ways. Now, if I ask you the same question in a slightly more difficult manner, so let's say we have the set of first 10 natural numbers, or let's say 9 natural numbers. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Now, if I ask you to form a 3-digit letter, where, the repetition of the numbers are not allowed. So how you are going to do it? You can try to do, start writing all the combinations first. So it will be a very tedious job. It's not that easy. So why not try to formulate something and see that it can be done by some specific method, right? So in order to do that, we will use the multiplication principle. So this problem can be solved via the multiplication principle. So let's see how we can do that, right? So we have 3 places. We have to form the 3-digit numbers, right? So we can easily say that there are 3 places which needs to be filled. 1, 2, because these are the 3-digit numbers. Now we will try to fill it one by one. So how many ways the first place can be filled, right? So we have the number from 1, 2, 3 and 4. So how many ways you can fill this place? This can be filled by 4 ways, as you can see, right? 4 ways. Now let's say 1 is filled into this place, in this box, we have put 1. So we are left, since the repetition of the numbers are not allowed, so we are left with the 3 options here for the second place. And similarly, if we place, let's say 3 here, so we are left with the 2 options, that is 2 and 4. So that can be done via 2 ways. So by multiplication principle, first place can be filled by 4 ways, second place can be filled by 3 ways, and the third place can be filled by 2 ways. Henceforth, the total number of ways will be nothing but 4 into 3 into 2. That will be again comes to 24, which is same as what we have achieved here, right? By simply counting all those numbers. Now, what is the theory behind it? So we have to fill. So now again, let's look at this problem. So we have 9 numbers, and we have to again fill 3-digit numbers, right? So we again do the same way, and we start with the 3 spaces. The first space can be filled via any of the 9 spaces, so that will be 9. The second space can be filled via any of the 8 spaces, 8 numbers, because the repetition is not allowed, and the third via 7. So that will come into 9 into 8 into 7, right? It is sometimes it is easier to represent this kind of a arrangement by giving a certain notation, and then we try to figure out mathematically what this notation means. So we say that arranging n different, objects, no, arranging, so we say we have to arrange n different objects taken r at a time. So what this is called? So we'll write this down as a statement so that will make your life a little bit easier. So we will say arranging n different objects taken r at a time. So we call this term as permutating n different objects r at a time. So we can say this as permutating n with r at a time. So that we denote it as NPR, right? So let's try to see what this NPR exactly is and how we are going to find this NPR. So if you look the same problem, of arranging the four numbers taken three at a time, which is same as forming all the 3-digit numbers, where ordering is important and repetition is not allowed. So it will come to, so we have already seen this. We have seen this, that 4p3 is nothing but 4 into 3 into 2. So what you are exactly doing is you are starting with 4 here, reducing it by 1, reducing it by 2, and you are repeating the same method till 3 times. So similarly, NPR can be represented as n. So you start with n, then you multiply with n minus 1, then you multiply with n minus 2, and henceforth till you reach here n minus r plus 1, right? So here we have seen that we start with, so here our n is 9 and again r is 3. So we started with 9, then we multiplied it with 1 less, then we multiplied it with 1 less. Similarly, we have to find, let's say, 9p, let's say 5. So what we are going to do is that we multiply 9, then we multiply it with 8, then we multiply it with 7, then we multiply it 6, and then we multiply it with 5. So there are 5 terms, right? So this can also be written as, if you multiply it by 4, 3, 2, and 1, and then you divide it by 4, 3, 2, 1. 3, 2, 1. So we define this thing that multiplying from 1 to 9 as factorial n, and since we are again multiplying it with 1 to 4, so this is factorial r. Now what is this? If we put it into terms of NPR, so it is easy to see that NPR is nothing but factorial n by n minus r. But by using the multiplication principle, you can do it like 5 times, 6 times, and keep on doing that, and you will get the same result. Or you can simply take this factorial and divide it again. So that will be the same thing you will be doing for both these cases. But it is easier to represent this as this. So let's try to see what is. So we have, let's say, a set of n natural numbers or n objects. You can say nn. So this is again all different till n, and how many ways you can arrange them in a row, right? So that the ordering is important here. So again we can start with the n first, right? Then we multiply it with n minus 1, then we multiply it with n minus 2, and hence we have to arrange the n objects. So finally we will arrive at 1. So this is nothing but factorial n, right? So this is one way of understanding the permutation. It is nothing but arranging this word and using the multiplication principle. How many ways you can arrange these objects taken r at a time where ordering is important. So when we solve various problems, you will understand when you will need to use the ordering and when you don't need to use it. We will see that in our next sessions. So for this session, I'll be finishing here, and in the next session, I'll be talking more about the subsets.